Your quiz review solutions, and your quiz will be exactly as this. The direction's the same. Intervals of increasing, decreasing, determine any relative extrema, intervals of concavity, and points of inflection. Okay, so start with the first derivative. Two over x to the 1/3 minus 2. Y prime equals 0. Y prime does not exist. The derivative doesn't exist when x equals 0. Now this first condition, and I'm sure I've said it to almost every single one of you in class today, don't just think that this condition won't give you any critical numbers. Set the function equal to 0. Alright, dividing both sides by 2. And then how do you solve this? Cube both sides. So 1 equals x. So on our number line, critical numbers of 0 and 1. If you plug in any negative number, it'll make the denominator negative. So that interval will be negative. If we choose 8, the cube root of 8 is 2. 2 divided by 2 is 1. 1 minus 2 would make it negative. And then, alright, hold on, cease. If we pick 1/8, cube root of 1/8 is a half. 2 divided by half is 4. 4 minus 2 would make this interval positive. So y is decreasing. Increasing between 0 and 1. So possible relative minimum at 0. Plugging 0 in. The y value is also 0. And a possible relative max at 1. Plugging 1 into the function, we also get 1. So we do have our relative extrema. Okay, so now the second derivative, again using the power rule, subtract 1 from the exponent. The derivative of -2 is 0. -2 all over 3x to the 4/3. The only critical number comes from where the second derivative does not exist, and that occurs at 0. Now the denominator, remember a rational exponent. Numerator represents the power of the base. Denominator represents the root. So your numerator will always be negative. Your denominator will always be positive. So the second derivative is always negative. Therefore, y is concave down on the entire interval. And you do not need to split it up at 0 because the function exists at 0. It's not a discontinuity. And therefore, no points of inflection because there was no sign change on the second derivative. Alright, number 2, polynomial, first derivative, 3x squared minus 6x. Factor out of 3x, x minus 2. Domain is all real numbers, so the derivative always exists. Critical numbers of 0 and 2 on the number line. -1, 1, and 3. If we plug -1 into factored form, we're getting a negative times a negative, which gives us a positive. Plug 1 in, that interval will be negative. If we plug 3 in, this interval will be positive. So y is increasing, -infinity to 0, 2 to infinity. Decreasing from 0 to 2. Because the domain of the function is all real numbers, we'll have a relative max at 0, 3, and a relative minimum at 2, -1. Okay, so the second derivative, 6x minus 6. Second derivative is 0 when x equals 1. Second derivative always exists. Putting 0 into the second derivative gives us negative value. Putting 2 in will give us a positive value. So y is concave down from negative infinity to 1. Concave up from 1 to infinity. And a point of inflection is at 1. Negative 2 plus 3 is 1. Point of inflection at 1, 1. We will have talked about these in class, but all of these values come from the original function. Okay, trig, and this is on the open interval from negative pi over 2 to pi over 2. Now, again, just to think about test values and where this interval lies, it's in the first and fourth quadrants. First derivative, 2 minus secant squared of x. Secant is the reciprocal of the cosine function. So the derivative doesn't exist when the cosine function equals 0. And we have had this domain on previous problems. In this interval, the cosine never equals 0, so we wouldn't get any critical values from that case. Where does the derivative equal 0? 2 equals multiplying by cosine squared x. Taking the square root, we get plus or minus square root of 1/2. If we were to rationalize this, it'd be plus or minus square root of 2 over 2. So this reference angle is pi over 4, and because of the interval, we're only looking at the positive value because we're only in the first and fourth quadrants, and the cosine is positive in both of those quadrants. So our critical numbers, negative pi over 4 would be the fourth quadrant angle, pi over 4 would be the first quadrant angle. Okay, negative pi over 4 would be here, pi over 4 in that region. So between negative pi over 2 and pi over 4, we would want to pick this exact value, and that would be negative pi over 3. We can choose 0 in this interval, and then we would choose positive pi over 3 for that interval. Okay, so back into the derivative. Y prime of negative pi over 3, 6, 4, 3, the cosine, so 2 minus the reciprocal of 1/2 is 2, square that is 4, so it gives us a negative interval here. When we plug 0 into the derivative, cosine of 0 is 1, 2 minus 1, that would be a positive, and then that would give us a negative because it's the exact same value as negative pi over 3. Okay. So what does this tell us about the function? y is increasing, negative pi over 4 to pi over 4, and y is decreasing. Don't forget the domain restriction. We have a relative minimum at negative pi over 4, plugging that back into the original. 2 times negative pi over 4 minus tan. In the fourth quadrant, tangent is negative, so this would be minus negative 1. That would give us negative pi over 2. So relative min at negative pi over 4, negative pi over 2 plus 1. And then a relative maximum, y of pi over 4. The only thing that'll change from the minimum values, it'll be a positive pi over 2. Tangent is positive in the first quadrant, so minus 1. Right, so first derivative 2 minus secant squared x. Second derivative derived using power rule, and then the derivative of the inside, the secant tangent. So rewriting the trig functions in terms of sine and cosine. So the sine function equals 0 at 0. The second derivative wouldn't exist where the cosine equals 0, but we already said in the interval given, there's no critical numbers from that condition. Okay, in the fourth quadrant, so negative pi over 2 to pi over 2, the sine is negative and the cosine is positive, so it would give us a positive numerator and a positive denominator. In the first quadrant, sine is positive, so it would keep the numerator negative and the denominator positive. So y is concave up from negative pi over 2 to 0, concave down from 0 to pi over 2. And there's a point of inflection when we plug 0 back into the original. Tangent of 0 is 0, so the origin would be a point of inflection. I'm running out of time, so I'll do number 4 and I'll sketch them on another video.